Hello, friends out there. Today we're studying global change, the greenhouse effect. Now, there's a lot of confusion about the greenhouse effect out there, so let's clarify some of these myths, if you will. All right, on page 521 yesterday, we talked about some of the different greenhouse gases. Now, what are our probably three main greenhouse gases that affect the temperature of life on Earth? Water vapor, carbon dioxide, methane. Now, it lists a couple others here in your book, nitrous oxide and chlorofluorocarbons, and we're going to get into those. So those are also considered greenhouse gases. Now, for you AP students out there, I will say this. I have seen a question in the past that was like, which one of these is not a greenhouse gas? So it's important that you're familiar with these different greenhouse gases, okay? But before we get into that, let's go back over and talk about the distinct differences between climate change or global warming and the thinning of the ozone layer. So for 7th period yesterday, I made this handy chart on the board, as you can see here, very sophisticated. Did we do this?
Yeah.
No, I think it was 7th period.
No.
So
I have the chart written down.
We reviewed it and write it for us.
Oh yeah, we definitely talked about it. Yeah, I wrote it down on the board for them. All right, so the global warming / climate change. Now, back in the day, it was primarily referred to as global warming. Now, a lot of times you hear it referred to as climate change just because there's a lot more to it than just a temperature increase. So, Andrew, can you grab that stick out of there and before it breaks and just lean it up against the countertop? So, the primary cause of global warming is excess greenhouse gases. So we talked about what are those greenhouse gases: water vapor, carbon dioxide, and methane. So it's the primary cause of that global warming / climate change that we see and we hear a lot about. All right, the effect of global warming, or the effect of that increase in greenhouse gases, is an increase in temperature, okay? And that's where we get the climate change. So over the past century, you have roughly a degree increase in temperature, which doesn't sound like a lot. Over the next century or so, or by the end of the century, it's expected to go up another degree or two, which doesn't sound like a lot. But when you talk about a degree or two may move sea level a foot or two, well, that's pretty substantial, especially if you're living on some low-lying island in Southeast Asia and you only have a few feet of sea level that you're working with anyway, okay? So obviously for us, we're like, well, what do we care? We're 250 feet above sea level here. Well, there are some climate issues that may result, maybe stronger weather, harsher weather, like we experience a lot of tornadoes anyway. In some places, it may not just be warming. It may be like you have stronger snowstorms in the winter. So it's not just an increase in temperature. Some places that experience a much higher temperature increase than others, and we'll get into that. A lot of that's typically in higher latitudes. So like in Alaska, Canada, Scandinavia, those places typically have a much higher increase in temperature than just the 1 degree. So it's not affecting everyone equally, okay, when we talk about climate change. Now, in the thinning of the ozone layer, which we talked about yesterday, a lot of times we say hole in the ozone. It's not really a hole. It's just a very thin layer of the ozone, or it's thinned a lot at a certain time of year, especially in the early springtime. And we typically think of the most problematic area of this being in Antarctica, okay? And so the primary cause of the thinning of the ozone are CFCs. Now, CFCs, I know what you're thinking. CFCs, we've already banned those. What else can we do? Well, not a lot, but we still got to deal with the ramifications of that. So it's one of those things where when you do something bad, then you make sure you learn from those mistakes. We've replaced CFCs with HFCs, which doesn't thin the ozone, but it causes what other issue? It's worrisome because it may be a very strong greenhouse gas. So that's a problem that we've got to worry with, okay? So now, the thinning of the ozone, what does that do? The effect is it increases UV radiation, especially UVB and UVC rays. Remember, UVA rays are already pretty much coming through all the way, and then UVB and UVC rays, most of those, like 99%, are blocked out by the ozone layer. And so when you have a thinning of the ozone layer, it's not going to block out as much. And so those are the differences. Remember, this is UV radiation coming in, and causing like skin damage and DNA damage, and it can be, damage plants and stuff as well. So it's not just humans, it can damage lots of organisms. And global warming, this is climate change, this is a temperature increase that's causing changes. Okay, so they're really two different issues. Now, there's one thing that they have close in common, though. Okay, and so CFCs are a type of greenhouse gas, a very potent greenhouse gas. Now, there's not a lot of them in the atmosphere compared to like CO2 or water vapor, but there is some in the air, and they're very potent. As you can see by the table on 521, it says they're anywhere from 2,000 to roughly 13,000 times as bad as a molecule of carbon dioxide. So that's pretty bad. Now, I would say probably it's a lot less significant than water vapor, CO2, but it is a greenhouse gas. So that's one thing that is in common with the thinning of the ozone layer, where the primary cause of this is CFCs. Okay? So CFCs can deplete the ozone layer. CFCs can also be a greenhouse gas. But the resulting effects are two different things. One is more UV radiation, and the other is increased temperature and changes in climate. Okay? So make sure you know the difference between those two things. Now, in your notes, we're on number 5 on the greenhouse effect. And one thing that we need to make sure we discuss here is the morality of the greenhouse effect. Is it good or is it bad, Jason? Greenhouse effect, is it good or bad?
It depends on where you live.
What do you mean?
I mean, I feel that, sometimes when you live closer to the equator, it's usually warmer there, so they're accustomed to warmer weather, but like you live closer to the Antarctic or to the Arctic at the north, you might be more used to colder weather, so if it gets warm, it might be harder to adapt.
That's an interesting way to think about that. I don't know if I agree with that, but that's an interesting way to think about that. I would think if I was living in colder climates, I would be like, hey, a few more degrees, let's do this dance. Jordan.
I think if it's natural, it's fine, but if it's too much greenhouse gas in the air, it's bad.
Jeremiah.
That's exactly what
All right, so the correct answer is the greenhouse effect is good. So just in terms of itself, greenhouse effect is good. Why? And I think, Jordan, you said natural, right? Yeah, so naturally, the greenhouse effect is good because it helps to moderate temperature of life on Earth. So it makes sure that we don't get too cold or too hot. The greenhouse gases in the atmosphere help to hold in a certain amount of heat. And this is especially important, at nighttime. You don't want it to be warm during the day and then at night it dropped to like 30 below and then all of us freeze to death. So I don't have the data. This would be a good extra credit for you guys. But on the surface of Mars, like if you were at the equator, it would warm up during the day. I don't know what it gets, maybe 30, 40, 50 degrees. But at night, you would see a dramatic shift. It may be like 50 below. So those numbers probably aren't exactly right. But my point being, because there's not anything to kind of hold in the heat from the day, then especially since Mars doesn't have water like we have water, there may be some water there. We're not really finding a lot of water. But because so much of the Earth is covered by water, it absorbs a lot of that heat, and then at night it releases it. And so the greenhouse effect helps to hold in some of that infrared radiation, which helps to keep us warm. So we don't want to be too cold.
It would be hotter near the water?
It would be more moderate near the water. Remember we talked about water helps to absorb heat. So when it's really hot, it's going to make it a little bit cooler. And then water also helps to release heat. So when it's cooler, it's going to release some of that heat so it doesn't get as cold as the inland areas that are away from the water. So that's why when you go to, for example, I went to Alaska when I was in 2003 after I graduated. And if you go to Anchorage, which is on the coast, it's on the southern part of Alaska, and it's on the coast, in the summertime, it's pretty moderate, maybe highs in the 70s for the day, and at night, maybe in the 40s. But if you go up to Fairbanks, which is in kind of the center of Alaska, okay, in the summertime, it was like 90 degrees out. And even though it was much higher in latitude. And that's because it's farther inland. There's no real moderating effect. So a lot of sunshine heats up a lot. Now, in the wintertime, if you look at the temperatures, Anchorage, because it's near the ocean, it's cold there, but it's not, it's like 30, 40 degrees kind of average because the ocean is giving off some of that heat because of the moderating effect. And you go up to Fairbanks and you may be talking about at night. I had a friend who worked at the air base up there, and he's like, a lot of times it'd get like 50 or 60 below. And so you're talking about, a dramatic shift in the temperature there.
I can't even imagine 50 below.
Yeah, that sounds cold. So I can't either. Yeah, what that would be like. I think like 20 here, that's like freezing. You're really cold with a lot of clothes on. So anyway, anytime you're near a body of water, it has a huge moderating effect. But greenhouse gases in general, especially water vapor, helps to hold in that heat and maintain more of a stable temperature. So you can see that here in the summertime, right? In the summertime, it's hot, it's kind of muggy here. During the day, it gets up to like 95, and at night, it goes down to about 75. If you go out to the desert Southwest at about the same latitude, during the day, it's often like Arizona, New Mexico, you're talking probably 110, 15 degrees a lot of times. And at night, it may go down to 40, in the 40s or 50s. So you have a huge temperature swing, and most of that is due to the water vapor in the atmosphere. And so the greenhouse effect is important in maintaining kind of a stable temperature at life on Earth, okay? So greenhouse effect is good. Too many greenhouse gases, bad. What you got? Oh, thank you. This is Krista right here. Everybody know her? Academic All-Star. Congratulations. And that person, thank you for closing the door. What's her name? Okay, so Aislinn? Aislinn? Like in The Lion, the Witch, and the Wardrobe?
No.
Isn't that the name of the line? That's okay. So, where are we going? So, greenhouse effect is good. Too much greenhouse gases are bad, and so can increase temperature and climate. Now, I want to throw this out on the internet, and so just be careful and don't take this out of context. Let's talk about some controversy behind climate change, okay? Don't give me that look, Rachel. So, as you probably know and have heard on social media or from some of your family members or other people that you associate with, there is some controversy behind climate change. And what is it?
That's not real.
It's not real. It's a hoax. Every time that it gets cold or snows, you see a meme out on Facebook that says, "What global warming?" So, yes, I have a family member who does these kind of things. Basically, one important thing to note is just because it gets cold or it may snow, that is weather. That is short term. That is not a climate event. Climate is the average temperature over a long period of time, like over the course of a year. And so that's one thing to keep in mind. The second thing to keep in mind, and I'll give you, there's some people who just say the climate's not heating up, it's humans can't affect it, blah, blah. So, and then there's another group of people, and these are the more sane of the two, I would say, or there's two sane ones and the other ones I'm not sure about. No offense. Is you have people like James Spann who study the weather, study the climate, and who isn't convinced that anthropogenic climate change or the increase in temperature is caused by people. His suggestion is that it's more of there's natural fluctuations. Like if you think back to like the last ice age, very cold, and temperatures have warmed up, and so temperatures have fluctuated. There's been kind of a short cooling period. I want to say back in the 1600s, there was like a little mini ice age or something. I don't know if y'all ever heard of that. And then there are just general fluctuations in temperature, and so. Some people would suggest that this is the temperature increase that we're seeing is one of those natural fluctuations in temperature. They what? Yeah, I mean, the temperature is constantly changing. And so you see these fluctuations from like century to century or every few thousand years. And there's a lot of variables that come into play, like solar radiation, ocean currents, a number of things. And then you have more of, I guess, the mainstream scientific community who would say that the temperature is increasing. Now, I don't know anybody in the scientific community that says the temperature isn't increasing some, Okay. The mainstream scientific community would argue, when I say mainstream, like most of the people in the scientific community would argue that the temperature is increasing and it's primarily due to human-caused activities, mainly an increase in greenhouse gases. And so where we have we burn a lot of stuff with CO2 and we cut down a lot of trees that would normally take in CO2, so you have a lot more CO2 in the atmosphere. If you increase gases, greenhouse gases that act like a blanket, you make the blanket thicker, the temperature is going to rise. And so that's primarily a human issue. And so that's what most scientists go along with, or how they think. So now for you guys are going to have to be objective. You're going to have to read, and think about it and make your own decisions. But I would suggest on the AP exam that you write down from the latter perspective that climate change is a anthropogenic issue. People have caused it, and it's due to those increasing greenhouse gases that we see. Any questions? Any thoughts? Okay.
I have a question.
Yeah.
So, does like the mainstream science community, like this is an actual question, I'm just wondering. Is it all caused by anthropogenic, or is it like there is?
Oh, could there be some natural fluctuation?
Yes.
I don't know. Did I hear a lot of that discussed? Like how much, if it's partial one, partial the other, if it just influences and kind of pushes it in one direction. If it's kind of like a car rolling down a hill and you're just pushing along farther with the extra greenhouse gases. That's a good question. I don't know. Here's my motto, that even if you don't think that the increase in temperature is human caused, we have a lot of very negative impacts on the environment, and we should all be doing a better job of reducing those. And including how much toxic, harmful gases we emit. And so the better we can make the earth, the better off we'll be. Now, whether it's human or whether it's natural, I don't know that I can say with 100% certainty, but it seems logical that if you increase greenhouse gases, that it's going to increase the temperature. Now, where do you guys see the greenhouse effect on a daily basis? Speaking of greenhouse effect, hold on.
The air.
Oh, we're back. They've thought about how they see the greenhouse effect on a daily occurrence. All right, who's got one?
The air.
Where do you see the greenhouse effect take place? Yes.
What about like the temperatures over the humidity? That's what I'm
You
thinking.
experience it in a significant way and see it and feel it.
No.
I mean, I don't know that you could detect a degree difference.
You sweat because it gets hot.
What happens when you get out of school on a sunny day?
Oh, it's cold in the morning and hot at night.
Sure, yes. What else?
Like when you get in your car,
When you get in your car, Colby, what happens?
it's really hot in here.
It's hot as a tater. So if your car has the windows up and you have no sunshade in, then you go out there and it's on a sunny afternoon, even if it's a cooler time of year, then your car is significantly warmer than the surrounding air. Why is that, Luke?
Because the heat gets like trapped in there.
Okay, so you have infrared radiation, okay, that heating up radiation that's coming from the sun. We have UV rays, infrared rays, we have visible light, blah, blah. So the infrared rays come into the earth, and you can see this on page 520 here pretty explicitly. And it comes in, and some of those rays are absorbed, which helps to heat up. Some of them bounce back, and then they are reflected back in by greenhouse gases. And so in your car, that infrared radiation comes in, it gets it heats up the faster the movement of those waves heats up the particles inside the car, which heats it up. And for many of you, then that gets trapped inside. And when you open up your car, it's hot as a tater, right? Now, side note, what's 2 ways to combat that, Rachel? Like, do you like going out to your car in the summertime and it being like 150 degrees?
No.
What can you do?
Put a sunshade up.
Sunshade.
Park under a tree or something.
Well, that's another good one, like park under a tree or some type of shade.
Some type of shade.
If that's not available, you can always have a sunshade with you, which you put up in your windows to block out and reflect most of the sunlight, which does wonders for your temperature in your car. And another thing that helps out a lot is,
Tint your windows.
Yeah, tinning can help out some. What else?
Um,
Maybe a simpler one than tinning.
Roll down your window.
Well, rolling down your windows is problematic, especially if you're worried about rain, which we have lots of storms. But you can roll down your windows if you have
if you have a Tesla.
vent shades, right? Does anybody have those little vent shades that go on the outside of your window and they kind of overlap the window where you can roll them down? Only old people do that.
I know what you're talking about.
You know what I'm talking about?
Yeah.
Like you can buy them for like, I don't know, 40 or 50 bucks at AutoZone or online. And basically they just kind of stick on the outside of your window, or you can buy the ones they can shove up in your windowsill. But basically, like you can, if you have those, you can roll your window down like an inch or two. And in the summertime, if you have a reflector in the front, which those are pretty cheap, and you have vent shades where you can roll your windows down so air can move in and out, it's not a big difference in temperature inside your car than it is outside. So I would suggest, unless you like getting in a 150 degree car every time, you know, that's something to invest in when you have a vehicle. And I know that helps me out. Yes, especially when you have kids and you're getting in and it's hot. I mean, I hate getting in a car and it's just like super hot, especially if you have a black interior.
I got black leather.
Black leather, that's the worst, yeah.
Awful.
That will like burn your legs
I
off.
hate seeing dogs trapped in hot cars.
Yeah.
I hate when people do
Who
that.
does that?
Yeah, that's kind of most people don't do that anymore, but unless they want their windows busted out.
And then they'll have the window down just a little bit, and then expect the dog to like put their head out the window, and they in the grocery store or something. Like this,
And the dog's purpose, there was a truck, and the puppy was in the front seat, and the mom was walking by, and she saw the puppy, and she said, "Nuh-uh," and then they busted the window, stole the puppy, and ran away, and that was the dog.
And the dog's purpose? Interesting.
I think
Okay.
that's about it.
So, we've clarified a lot of ethical and moral issues here today. Number 5, let's go through the notes here. The principal greenhouse gases are CO2, methane, which is CH4, remember, and water vapor. Okay? They also include nitrous oxide and CFCs. Like I said, you're likely to see a test question or a quiz question that asks you, like, which one of these is not a greenhouse gas? So make sure you are familiar.
CO2, CH4, and
Carbon dioxide, methane, and water vapor, along with our friends nitrous oxide and CFCs. We talked a lot about nitrous oxide being produced as a byproduct of fossil fuel combustion, especially like in cars. Methane, we haven't really got a lot into methane, but we're going to. There's a number of sources of it. All right, number 6. While water, I don't really like how they word this, but I'm gonna try to explain why I think they worded it this way. So I'm reading directly. These notes came directly from the College Board this way. While water vapor is a greenhouse gas, and I would argue a significant one, it doesn't contribute significantly to global climate change because it has a short residence time in the atmosphere. Now, I think they're trying to say because water moves between the oceans and the air, and I think they're trying to maybe say that we don't have a huge impact on where water is in the biosphere, but I just don't really like the way they put that. Water is a significant greenhouse gas. I don't know that we can say it contributes significantly to climate change or global warming, though, because why?
We're not producing it?
Yeah, I mean, we've had water around. It's still around. I mean, it's going to be around in the future. We're not producing or putting excess in the air. When we produce like excess CO2 or CFCs or methane, then that's a significant factor because it's something we're doing to cause that. All right, number 7. The greenhouse effect results in the surface temperature necessary for life on Earth to exist. And what they're trying to say here, and didn't do a very good job of either, is the greenhouse effect's a good thing. And we need it for life on Earth, and it's important for that. We just don't want too much of it, okay? So, and I'll say this again about the natural fluctuations in climate. You know, if you think back to, well, I mean, you don't have to go far south of here. I've been down to Sawyerville, which is just below Moundville, and you can go in creeks down there and find plenty of shark's teeth. So that means that the oceans at one point were not very far away from where we are now. So, which means most of the ice would have been at that time period
Oh, nothing.
frozen.
No, because remember that video of the Ice Age?
When the ice melts, what happens to the oceans?
They,
They rise.
They go up. So probably wouldn't have had much ice at that time. Probably would have been very warm. And we would have expected during the last ice age, what happened to the water?
Cryptids will go down.
For it to go down. And there's actually, if you go off the Gulf Coast, I don't know if you guys saw it in a video earlier in the year, the America's Amazon video. They talked about there's a forest off like 10 miles offshore of Gulf Shores where there's like an underwater forest, or there's just a bunch of trees out there now that are like on the ocean floor from where that was forested a long time ago, when ice would have basically taken up a lot of that water and kept it frozen, and so water levels would have went down.
You remember like the ice age, the ice came down to like mid-Alabama?
Mm-hmm.
I just love to think that like none of this was frozen.
What?
No, like remember like it talks about how the reason there were so many organisms is because when the ice age came and killed everything, it only reached about.
Yeah, glaciers never came down this far. I'm sure it snowed and stuff, but the glaciers, I think, probably reached down to maybe northern Tennessee or Kentucky.
That's the coolest thing ever.
Yeah, and so the reason we have that diversity is because everything didn't freeze up. Now, it was cold here. If you go to the Museum of Natural History over at UA, there is a mastodon, which y'all are familiar with woolly mammoths. Mastodon's like its little cousin. And they found that joker down in Demopolis, I think, which is about an hour south of here. So I know we think of watching like the movie Ice Age and think of woolly mammoths and being up north and where it's cold, but mastodon was found not far from here. So, and I don't think that was an uncommon occurrence either. And remember, if you're talking about glaciers, there's probably nothing really living close to those glaciers and hanging out. I mean, that's frozen ice that's solid all the time, and so that's definitely going to push life further south. All right, number 8 and 9. Let's finish these up, and we're going to get our gardening on. Number 8, carbon dioxide, which has a global warming potential of 1. So basically what they've done here is said we're going to make carbon dioxide our baseline. We're going to assign this arbitrary global warming number to number 1 to carbon dioxide, and it's going to be our reference for all the other global warming or greenhouse gases. So is used as a reference point for comparison of different greenhouse gases and their impacts on climate change. So in your book where it says carbon dioxide is warming, global warming potential is 1, that's why it says 1. That's the reference point. And methane is like 25 times worse than that. Nitrous oxide, 300 times worse than that. I don't know why there's this huge fluctuation in chlorofluorocarbons. Maybe there's different ones I'm not aware of. It says 1,600 to 13,000. But I guess the big takeaway is CFCs are a really bad greenhouse gas compared to carbon dioxide. Okay? And the bottom part of that note is CFCs have the highest global warming potential, followed by nitrous oxide and then methane. Okay? So that's talking about like molecule for molecule, pound for pound. Those are worse. Obviously, carbon dioxide is still pretty bad just because of the high parts per million that are found in the atmosphere, and that we're a primary reason for that increase in CO2. All right, does anyone have questions on that? Lots of fun topics.